我已经开了。
Okay. Hi, Daniel.
Hi.
Welcome.
Thank you for having me.
Yeah.
So today we are touring the
In the
facility,
factory,
the
yes.
whole factory. Okay.
Yes.
That is awesome.
So firstly, we will have a brief introduction of Runis and
Okay.
the Runis industry.
Okay.
And then we will do touring of the factory from the parts to the finished parts. And then finally, we will have giveaways.
Giveaway,
So,
okay.
listen carefully.
Yeah, we're gonna do some giveaways, so definitely pay attention. Awesome. We're gonna see how the products are made today.
Yes.
We're gonna go behind the scenes. It's something that's usually not people don't get to see. So it's very special.
Yes.
Awesome. So I think the plan we're starting with, these are some new products.
Yes.
So what do we have here?
So here is our new products, which released in October.
Okay.
Yeah.
And I recognize
This is
end coat.
yeah,
Okay.
exactly.
It
With
looks
the
V6 maybe or Mark
V6 type.
Okay.
Yes, Phaetus PS type.
Yep.
Yeah.
And then unicorn nozzle.
Yes, unicorn nozzle,
With
and
the-
this is end coat tip, and this is silicon carbide tip.
Oh, nice. Yeah, really high abrasive resistance.
Yeah. Especially for the composite fiber
Yeah.
filaments.
Yeah, carbon fiber glass filled.
Yes.
And then this looks like
For Prusa.
Okay.
Prusa, yeah.
So the
Also the silicon carbide tip.
okay, so the next extruder on the current hot ends that they have.
Yes.
Yeah. And then this is exciting.
FS2,
So-
FS version 2.
Yep, which
Yeah.
is completely different than the first
Absolutely,
version.
yes.
Yeah, the first one was much more open form factor with big outside gear. Well, this
Yeah,
looks
this is smaller.
yeah, compact, lighter weight.
Lighter
Yeah.
weight.
And
yes.
also, I think it has a built-in filament runout sensor as well, right?
Yeah. We attached the filament runout sensor inside.
Awesome.
Yeah.
And then what is this? I recognize, but what are these? These I think are
Yeah,
the,
this is the conch hot end.
okay.
Yeah.
So for the bamboo,
Bamboo
P
P1S and
Okay.
X1
okay,
series.
P and X series.
Yes.
And then there are two versions.
Two
of it.
versions, which the first one is the conch hot end and with the end coat tip,
Okay.
and the second one is the plus version with the silicon carbide tip.
Okay, so options for both on all of them. And the main distinction is the silicon carbide is for someone that's very heavy abrasive printing,
Exactly.
right? Lots and lots of
Yeah.
printings. While the end coat will still let you do a lot of that printing, but it's not as longevity as far as material printing through it.
Yes.
So if you're printing with a lot of abrasives, the silicon carbide is the way to go.
Yes.
Yeah, okay, perfect. And then are we going to set these up right now, or are we going to have these set up?
We could take a quick assemble, and
Okay.
then we do touring of the factory.
Okay.
And then we back to see.
Take a look at it. That sounds great.
Yes.
Yeah.
Okay. We could come for the assemble. Okay. For assemble. Yeah.
This is the Ender 3 V3, right? I believe. Well, they're installing those. Do we want to continue a little bit?
Yeah, we'll
Okay,
continue, yes.
on. So
Okay.
I know you mentioned a moment ago Runis.
Yeah.
Which Runis is something that I was not familiar with prior to briefly talking about Runis. So can you explain, just briefly for those that don't know, what is Runis?
Of course. Yes. Runis is the components maker for 3D printing. So
Okay.
we could see this.
So we got some examples over here of what Runis produces.
Yeah, we focus on 3D printing parts,
Okay.
like the nozzles, the heat brakes, gears, and transmission parts.
Okay, so both for the hot end filament melting and processing,
Yes.
as well as actual motion of the printer itself.
Exactly.
So driving the different systems.
Yes. So here we could see for nozzles we have different orifice. Even we could do 0.1.
I don't think I've ever printed with smaller than maybe 0.2 out of fear that it's going to clog, you know.
Yeah.
But if you want it, they've got 0.1 all the way up to 1.2, and it looks like lots of different materials.
And also different materials for different filaments.
So we have brass, hardened stainless, copper, DLC for where is
for
this?
hardened steel,
Rubies,
yeah,
yep.
tungsten carbide, and even our end coat.
And then what
or
are
silicon
these?
carbide.
These are, is this PTFE or what is
PTFE, yes.
Interesting. And that's to print with-
non-stick.
Gotcha. So if you're printing with something and you're having a lot of issues with buildup on the nozzle, this
Yes.
will prevent that from happening.
Yeah.
That's awesome. Okay,
And here we could see we make the long
yeah,
length
yeah.
of
This
the
looks
flow.
like this
Yes.
looks like almost super volcano.
Yes.
This is like standard, maybe high flow, and then like super high.
Yes.
Yeah, exactly.
Yeah, for the small in the hole we get a good roughness.
Yeah.
Yeah.
Yep. Awesome. And then yeah, we've got some. These look familiar. I recognize this is the
Dragonfly.
Yep, I'm very familiar.
Yeah.
And this is that water?
Water cooling.
Interesting. Okay, so
And
liquid
this
cooling.
is the copper
Yep.
heat break.
Yep,
Yeah.
bimetal.
Bimetal,
Yeah,
yes.
exactly. And those are basically press fit together, the two different alloys.
Yes.
Okay, that's awesome. And then I
And this
recognize
is
all
the
these, the gearing. Yep. Hardened
extruder
steel
gears.
with nickel plating, and then we've got the
This is RNC coating.
as well.
Yeah. So also with this BAM lab kits,
Yeah.
we do the upgrade. Also
oh,
do
nice.
some different materials and
Cool.
also different coatings.
Gotcha. So this looks like a CNC arm for it,
Yeah,
probably.
CNC arm,
Yep.
yes,
And then
RNC coating.
Yep.
Yeah. Also, we optimized the shape of the
interesting. So you
Teeth.
changed the gearing of the teeth, or not the gearing, but changed the sort of geometry of the teeth a little
Yes,
bit. Okay,
yes.
interesting. Okay, cool.
and
Okay.
this is the transmission parts, the pulleys.
For movement.
Yeah.
So Runus, again, is a 3D printing manufacturer for OEMs.
Yes.
Okay, and
And
you can
here we can see we founded in 2013, and
wow. Okay,
till now we have 11 years.
I didn't start 3D printing until 2014. So you guys have been even longer than me. So that was Runus initial introduction. And when Runus started, was it mostly nozzles initially, or what were the main like the initial components?
All the components for 3D printing.
All okay,
Yes.
all the different components. Okay, and then we.
And we're expanding in 2017. Yeah. This is our first expanding of our factory.
Big expansion.
Yes.
How many times have I know you mentioned this is a fairly
The-
new facility.
the fourth.
This is the fourth. Okay, so lots of moving throughout the years.
And in 2019, we created Phaetus. So this is our brand,
Okay, so
especially for the carbon fiber filaments applications.
so for those that are wondering, Runus is sort of the parent OEM brand, and Phaetus is the first party products being made. Okay.
Yes.
And so yeah, this is so 2019, so 5 years for Phaetus is a long time.
Yes.
And then the Dragon Honden, which the Dragon Honden is my first experience with Phaetus actually. It was recommended for the Boron Zero build, the high flow version with the ceramic heater.
Yes.
And it's been an absolutely awesome Honden. So I'm definitely familiar with the Dragon Honden.
Yeah.
And then we're moving forward a little bit more.
In 2021,
Okay.
we acquired Job Effect, and also we invested in Fuselage.
Okay.
And focus on the composite fiber filaments.
And Dropvet, for those that aren't familiar, was a German company that made Omnia drop extruder. Yeah, so the really soft material printing.
Flexible rigid.
Very, very flexible. I tested out an early version of it. It was really impressive. So, okay, and then is this over here some of the different products from
Yes.
Phaetus?
So we could see here, this is our products from Phaetus.
Okay, so this is, we've
So
got,
this is new products
Yep.
we just mentioned, and this is our current products.
so I recognize,
This is Next-G,
yep,
Dragonfly,
Yep.
BMO, and this is a co-brand.
That's an interesting one to
Yeah.
see. I know that's with the coat print,
Print,
the,
yes.
the multi-color, multi-material,
Exactly, yes.
very large heat sink
Yes.
on that one. And then the Dragonfly,
Dragonfly
for the, like
BMS.
reality version.
Yes.
Looks
Rapido.
Like, mm-hmm.
Rapido 2.
Okay, Rapido 2, and then
Yeah.
I just recently
90 degrees.
Yeah, I just finished building the positron, so I just got to use this for the first time. That had to have been a new challenge,
Yeah.
right? At 90 degrees to make
Yeah.
sure the filament was able to feed through there
Yes.
effectively. And then this one I haven't seen.
Dragon UHF.
Okay, so this is
High
like
flow.
the ultimate high flow Dragon series.
Yes.
Awesome. And then back
And
here.
this is our filaments.
Okay, so these are the filaments, and we've covered a few of these on the channel. I know the carbon fiber PET is one of my, it prints beautifully and is very, very strong, but we've got,
Okay.
let's see, carbon fiber, this carbon fiber nylon high temp.
Yes.
Then we've got ABS glass filled,
Yes.
and down there we've got yeah, there it is, that's the one, PET carbon fiber.
Yes.
I really like that
And
filament.
also we have the coated filaments.
That's right.
Next PA, next PSF.
Yeah, because pretty much from what I'm understanding, most of the filaments that Phaetus is having are all like abrasion or like very specialty engineering filaments.
Yeah.
Right. I think I've seen there's like ESD, like electrostatic ones for circuit boards and stuff like that.
Yeah.
This is I like I like that one a lot. Yeah. That's awesome.
The cover is printed.
Yeah. It almost looks like a wood. It almost has like a wood grain to it.
Yes.
There's a coffee machine.
Yes.
Very cool. Awesome. And then
Okay.
let's continue down the road here.
Yeah. So
These are
this is our new product.
Yes.
Yes. And we expanding in future. So we focus on the 3D printing solution creation and including the extrusion system, the motion system, the composite fiber filaments.
Yeah.
And especially for the precision manufacturing.
okay. So for a lot of the high performance really is kind of what it is. It's for people. You can print with all materials, but a lot of it's specializing in being able to print with those same materials you have over there, right? Yeah, that's awesome. You need to add, I think, the new product somewhere up here, right? The Phaetus and those, they have to go up here somewhere too.
Yes.
Awesome. And then this, moving a little further, this is
This is our business plan.
Okay, I recognize the United.
Yeah, all of the world.
Yeah, I'm very familiar with Fabrico
Yes.
and West 3D. So these are
Yeah.
these are resellers.
This is resellers.
Okay, so
Yeah.
resellers in US,
Yes.
Canadian resellers, Mexico,
Yes.
and then this is
In Europe.
All
Yes.
Wow, all over Europe.
Our customers and resellers.
Okay, yeah, I'm familiar. I know 3D Jake and a few. I'm trying to see a few other ones on here that I know,
Outweigh.
and then a lot in China as
Yeah,
well.
this is domestic.
And these
This is our customers.
Okay, so these aren't necessarily resellers. These are because Creality and like Elegoo or Chidi. These are using some of the
Even
components.
yes.
Oh, yeah, even LDO. Yeah.
Yeah.
Okay, so they're using some of the components that are being produced here. Then.
Yeah.
Okay. Wow. Yeah, a lot of. Do you know how many in total?
Over 100.
Over 100.
Yeah.
Yeah, that's. I knew that there was a large footprint, but it's when you see it on the map like this, it's a very global footprint across the world. So that's awesome. Okay, and then we've got some numbers on the wall here.
Yeah. So this is brief introduction to Onyx.
Okay.
We have more than 150 employees.
Okay.
And we just mentioned 136
Reseller or kind of like big
customers.
yeah. Okay.
Yes. And more than 100 patents.
Over 100 patents.
Yeah.
Okay. That's a
And
lot.
here, this is patents. Till now, we have sold and over 600,000 pieces.
600.
Yes.
Is that just from the Dragon to now?
Yes.
Wow. 600,000?
Yeah.
Okay. That's a lot of patents.
And this is a nozzle. 5.5 million nozzles.
Oh my gosh. Okay. 5.5 million nozzles. That's
Yes.
crazy. That's awesome. This is very cool. Just overview. I imagine it has to get updated somewhat often. Right? As more hot ends get sold and the resellers get added. But
Yeah.
this is awesome. Very, I'm sure, rewarding to see all the hard work, right, of the team. So, and then what is this? What is this big wall here?
Yeah, this is some patents on our products.
Okay, so
Patents wall.
these are all patents, and these are looks
Part
like-
of them. Yeah.
these are the Chinese patents then.
Yes.
And this is
Especially focused on 3D printing.
gotcha. And this is to protect Runus from, if you're protecting yourself from the things that you've created, basically. Yeah, it's a very tall wall.
Yeah, we will update perhaps end of this year.
Update with some more. Yeah. Wow, that is quite the showpiece. Okay, so I think that's a bit about the history and sort of Runus and how Phaetus sort of started in 2017.
2019.
2019,
Yes.
and now we're going to move on to the
Factory.
This is what I think everybody is very excited to see. So let's take a look here. So this is the production, and
Here is our factory.
okay,
So all this model is our manufacturing for the parts.
what are these machines? They look like CNC.
This is the Swiss X.
Swiss lathes.
Yes.
They are. I mean, it looks like they are CNC controlled automatic.
Yes.
So okay, but they're lathes. So you've got basically like a tube being loaded sideways.
Yeah, two spindles and with a bar feeder. Raw material bar.
Copper.
Copper, yes.
Okay, so this is what it starts out as, and then it
And put
goes
into the bar feeder, and the bar feeder will load the bar
Okay.
and into the machine, and the lathe will manufacture automatically.
So it gets pushed in from there to here.
Yes.
And this goes through, and it looks like a nozzle is being made inside there right now. Oh
Yeah,
wow.
this is take care.
Yeah,
Yeah.
okay.
This is unicorn nozzle body.
Unicorn. Okay. So this is the copper we saw, and then what are you using for the coolant? It looks like
The cooling oil.
oil. Okay.
Yes.
Oil coolant. And then when the part is complete, it comes through. Oh, I see.
It comes from this channel.
Okay.
And our technician will take this part
Okay.
for the self inspection and then put into the fixture.
Okay, so it'll come out here, they'll inspect it, and when they inspect it, is it right now just a visual inspection, or do they have some kind of a gauge?
Yeah, have the gauge.
Okay.
You can see.
Oh,
this
there we
is
go.
online
Okay.
inspection
Yep,
gauges.
yep, okay, so this lets them
Pumping
make
and
sure that
gauge,
the
yes.
thread is correct on it. And-
Yes.
Okay, perfect. And then what is this? This looks like,
This is the fixture, and because the copper is easy to be anodized.
Okay.
Yeah. Oxidized.
Oxidation,
Yes.
okay. So this-
we will protect in the oil.
gotcha, so it goes from here, gets inspected, goes onto the jig,
Jig.
and then it goes
into
somewhere
the
else.
oil. And next we will move into the clean room.
Cleaner,
to
okay.
cleaning.
Okay, let's can we do a little bit?
Yes.
Yeah. So you said these are one more time Swiss lathes. And there's a lot of them. How many are there? 40? Okay. And then, so these machines then, I imagine this is producing the majority of what you're making. This is the main machine being used for like lots of nozzles and heat rates, these things. Okay.
Even pump gears.
Oh, even gears on these as well. Okay. And, I mean, all different materials, from copper to brass, titanium. Wow. Okay. Yeah, these are very awesome. Okay, so we walk around here. Spare parts. Okay, so this is for the actual the lathe, or this is for
This is for inspection.
Oh.
Because we have some
Gotcha. So
pin and gauges
Gotcha.
for inspection.
So basically, the part that you just showed over there, the
Yes.
gauge, is that all the different sizes of them here?
Yes, because sometimes our technician is easy to make the mistake.
Sure.
Yes.
There's a lot of different sizes.
Different sizes,
Yeah.
especially for example 2.01 and 2.07.
Sure. Okay, I can see that. Yeah.
Yeah,
There's
this is
sort of
easy to
similar looking.
Yes.
Yeah.
So with this system, we just input the part number
Yeah.
and the system will give you
And it's
the
been-
right pin.
I've been working on a very simple version of this for just my all my different screws at home. I need something like this. This is a much better solution than
But expensive.
I'm sure. Yeah, yeah. Mine are all printed, and I have to sort through them myself. But this is a really nice. This is a very nice way of organizing them.
Yeah.
So this is all you said pins and gauges. Is this entire section here? Okay. And then over here, this.
This is the tools for the equipment.
Okay. These look like bullets, right?
Yeah, bullets,
Okay.
yes.
And are these used to grab the bar stock? Basically?
Yes.
Okay. So, you
So
need
for different diameters, we have different
sizes.
size.
Yeah. So it
Yes.
looks like 12 to 21.
different size.
Yeah, smaller 10 to 16 millimeter, 7, down to very fine, 4 millimeter diameter,
Yes.
1 millimeter
Yeah.
diameter.
Yes.
Is that really 1.1?
Yes.
Wow. That is I wouldn't think it's very fun to work with such a fine diameter. It's probably quite difficult.
Sometimes we make the tubes.
Okay.
Yeah.
Oh yeah.
Very, very
Tubes.
tiny.
Yep. Okay, and
And
these
this is-
are all
this is
of
the
the
tools.
technicians.
Some tools.
These are for just changing out basically
Yes.
the collets. Yeah, I'm a little familiar. This is much. I have some experience with CNC, much smaller scale.
Yeah.
Much smaller. This is a lot larger than anything I've seen. My little ERC 11 collets, I think, is what I use. And these are also more.
Some tools. Those tool parts.
Okay.
Cut
Cutting tool. Okay, gotcha. Also, this is also for those same lathes.
Yes.
Oh wow, these are, I can see, very sharp, like, is it?
To assemble the cutting tools.
Okay. Is it hardened tool steel or?
Hardened tool.
Yeah. Yeah, those are, that's a lot of tools. That's awesome.
Yeah.
Okay.
So this is also the Swiss space, but we operate it with the robot.
Okay, so this is a robotic version.
Yes, because especially for some brass models, it's easy to dispatch it. So
Gotcha.
we take this robot to pick up the nozzle from the machine one by one and put it into the fixture.
So you're saying that because some of the materials like brass are so soft,
Yeah.
this prevents any accidental damage from happening.
Yes.
Because the robot places them versus a person grabbing
by
them
one.
from like a big tray or something
Yes.
like that. Okay. Yeah, that's awesome.
Yes.
So it waits for the machine. It waits for the machine to complete the part, and then it senses that the part's been completed, and it grabs it and places it in the tray.
Yes.
And then is this a belt or is this a manual?
This is a belt.
Okay, so
Yeah.
as it
will move.
it loads the next tray.
Yes.
Yeah.
So there are two layers.
Oh wow. Okay.
So
the top
when
and the
when,
bottom
when
layer.
the first layer finish, it moves down and move forward.
Yeah,
So automatically.
that is awesome. Is the plan to incorporate this for most of the machines, or only the ones that are needing it for like the softer alloy?
In future, we aim to make the factory into black factory.
Meaning automated.
Yeah,
Automated.
all the automated.
Yeah. Okay. So for now, start with the ones that need it, that benefit the most. But long term, the goal is to add more robots to
Yes.
basically help out with everything.
Yes.
Yeah. That's awesome. And then you know, tell us a little bit about sort of what the system is on here.
Yeah. So this is our MES system,
Mess.
manufacturing system,
Okay.
to do the checklist of the parts, the order, the parts, the quality.
Okay.
Yeah. So we have the order information here, the adjusted information, and the quantity, and even the issues, quality issues.
Gotcha.
Yeah.
So this keeps track.
Yes. So once the order transferred into the machine, our technician will take the drawings and the SOP
SOP is
SIP to adjust the parts.
SIP is the parameters, like technical parameters.
Yes.
Okay. So
Yes.
this is like tolerances and dimensions for all of the different parts on it.
Yes,
Okay.
for the online self-inspection.
Okay.
Yeah, so our operator will do the inspection 1 hour.
Every
1
hour.
Yeah,
Okay.
every 1 hour.
So this is similar to the first stage of the QC process.
Yes.
Okay. And then they sign off on it. That's what that is right there, basically.
Yes. And this one is the record from the IPQC. So IPQC is our quality department qualifiers.
Okay.
So they will do the inspection every 2 hours.
Okay. So you have QC here, but then you have what's called IPQC.
Yeah, IPQC is in process. In
Okay.
production.
So okay, while things are being manufactured, there's a quality assurance process or quality control process of that.
Just okay.
That's okay.
Yeah. So
they-
if every issue happens, they will write down the details
Right away.
and stop the machine.
Yep.
And the machine will check the lab, and our technician will come here for the maintenance.
Okay. And you said once every hour for the technician at the machine, and once every 2 hours, an external department comes and checks them
Yes,
as well. Okay.
yes.
So some redundancy there. Yeah. That's awesome. Thank you for showing. That's interesting to see kind of how the system works, you know?
Yes.
So
So here we could see our tool room.
this is the tool room? Some more tools.
Yeah.
More tools. Over there you said it was pins and gauges though.
And this is for tools.
tooling. Okay.
Yes.
Gotcha.
Some drills, some reamers, and millers. Yeah.
Gotcha. So this is
So-
how you keep track of all that.
Once the new tools come in, our technician will give it the code, and then scan the code and put the parts
In the
into
appropriate place.
cubic.
Yeah.
So that we can calculate the tool life with this system.
Gotcha. Okay. And tool life is something I imagine that's
The-
very important.
For quality control.
Yeah, because as the tool is used more and more, it probably doesn't work nearly as well, right?
Yes.
Yeah. Is there a process that you can sort of take a tool and make it a little bit better, or no? It's like as it's run through, once it's done, it's done.
Once the tool nears the tool life,
It's
we
done.
will,
Okay.
we will
Just pull it out. Yeah.
replace.
And the goal I imagine is to probably pull it out before you start running into issues from that tool not being. Yeah.
Yes.
Okay. So that's what this is, all tools, and this looks like a lot of tools as well.
This is the tool that being used.
Okay. So you've got looks like reamers, you said.
Yeah.
Some
The
drills.
drills. Yeah. And this is also the carbide alloys.
What is this type of tool? Like I've never
Yes.
seen. What is that considered?
This is the profile tool.
Profile tool.
Yeah. It's customized.
Yeah. All different sizes. So
Yes.
pretty large sizes down to. Those look like a couple millimeters max, right?
Yeah.
Yeah. That's. I imagine that keeping inventory of this is a task in itself. You know, it's a lot. There's a lot of different tools, and also, like you said, different materials as well, right? Depending on what you're machining.
So every week we will move away lots of broken tools.
Okay. From the straight, like you go get. Yeah. Okay. That's awesome. And these are also spare parts as well.
Yeah.
So lots of parts for the machines, basically. We're testing the parts coming off the machines as well as having all the parts needed to make sure the machines are able to create those parts.
Yes.
Yeah, that's awesome. Very cool.
Okay. This is our online self-inspection.
Okay.
Yeah.
And these
so
are.
That's machines. We have the online inspection every 1 hour.
Okay.
So our technician will do the.
Oh, this is really
inspection.
cool.
Yes.
Okay, so it's almost
This is the
it's almost like a microscope, a
Yes.
very high power, and you're able to see the teeth of the gears on them.
dimensions, yes.
And so this machine is used to check. I mean, it can check the diameter of a nozzle. It can
Yes,
check the
yes.
like orifice. Yeah. Okay.
But some parts inside, we will take the section out, so you will see in the IPQ center.
Okay.
Yeah.
So, but this room right here is also part of the in production checking.
Yes.
Okay.
Yeah.
Yeah. That's wow. The
But
detail.
from our technician himself.
Oh, okay, gotcha. So from the person that's operating the machine, they can take it themselves over here. It would be really nice to have one of these microscopes at home when I'm looking to see if I have issues. That's awesome.
Also expensive.
I know. I've got my little one that puts it out. And these are other parts.
This is for silicon nozzle.
Okay.
Yeah, the sleeves.
Copper then? No.
Yeah,
copper. Okay.
Yes.
And these are fresh off the machine, it looks like.
Yes.
Yeah, that's awesome. And you can see the details about all of that specifically there. This was for the the crowdy one.
Yes.
Okay. Yep. Yeah. It's crazy. The reflection off of there, it almost has a rainbow effect to it. No,
Yeah.
it does. It's really cool. looking.
Some oil.
Yeah. It's not. Yeah, it'll come off. I'm sure. Yeah. It looks cool though. So then we've got more, all the same thing. All the way across.
All maintenance.
Maintenance right now.
Yes. This is titanium tube.
Okay. Can we show the inside of the, I think the machine is, now that it's open here. This is really cool. So
This is all maintenance. Yeah.
so I see that there's multiple tools. So can the lathe also do tool casing itself?
Yes.
Oh, okay. So yeah, it's got, I see quite a few tools in there.
Yeah.
So you've got 1, 2, 3, 4, and then this one is machining
The titanium.
titanium.
Yeah.
Okay.
So even we have the fire extinguisher.
Titanium is very difficult
To touch.
alloy. Okay. So it's a smart issue or
Yeah.
something?
Yeah.
Gotcha.
If the smart happens, then it's easy to be fine.
Especially if you're using oil. Oil for the cooling,
Yes.
right? Okay. So safety first. That's good.
But we never use.
Okay, never. Okay. It looks old. Like it's been there for a long time.
This is also titanium tube.
Okay. Little setting them in place. And then it looks like also an additional step there.
Yes. Online
Yep. Okay. So you can inspect the outer diameter of the tubes.
Yes.
Yeah, that's a lot of checking. A lot of checking, it seems like, throughout the process.
Yeah, 40.
I guess this makes a lot of sense. I was under the impression it was going to be a lot more like 5-axis CNC machines, but because so much of what you produce is circular, it makes sense to use something like a lathe to machine them, all the threads and stuff like that. So, yeah, these are, I've never seen machines like this.
You know that 40.
Huge.
Yeah, we have 4 lines. Each line has 10 machines.
Each line has 2 machines?
Each line has 10 machines, so total 4 lines.
Okay, so that's their 40 of them. Yeah.
Yes, we have 2 shifts for 7 days.
So yeah, so you've got the day shift,
Yeah,
and
night
the
shift
night
and
shift,
night
and then everything you said 7 days a week.
Yes.
So these
No stop.
machines, they're running around the clock. Yeah. I imagine as long as you're busy, you need to keep those machines going, right? It's really important. So if there's ever something that happens with one of these machines, is it mostly a technician in-house electrician, or do you have to contact the manufacturer of the machine to help?
We will maintenance first ourselves.
Okay.
Yeah, so we have daily, we have weekly, we have monthly, and even quarterly
Okay.
maintenance of the machine.
So lots
we
of
want to let it.
lots of maintenance going on. So
Yes.
the goal is to keep them running in-house, and then if for some reason something happens, you could always reach out if you had to.
Of course.
That's not the goal. The goal is. Yeah, that's incredible. So that's all of the excess metal that's not kept for
Stainless steel.
stainless. Yeah.
Yeah.
Oh, cool.
Backstage. So the first we make some process.
This is some additional process. Okay. So this is
The tube.
titanium.
Yes.
So for the
For the-
heat break, right?
Yes.
Okay.
Yeah.
And
So
then,
we do the grinding of the out diameter.
so these are being taken from here, and it looks like he loads. He pushes them into this machine here,
And they
so it's great. The tolerances that you can achieve with this. grinder.
for these machines we can achieve even 3 or 4 micron.
Wow. So they're very, very fine detail. And then because this is titanium and it has to be grinded down, what kind of discs are those? What's the material of the disc that is grinding?
Mostly is the silicon carbide, even the diamond.
Okay,
Yeah.
so
So
very
make it
high.
very hot.
Based off of the outer diameter.
Mind you,
Yeah.
in future,
Yeah. So this is more grinding as well over
Same
here.
one, yes.
Okay. And same looks like same thing, right? It's
Yes.
the heat breaks.
same process.
Yeah, that's cool. So this happens right now to every single heat break for this is for the reality or this is for the
Reality.
Okay. So right okay.
This is for the
That's
out diameter.
That's
it.
So this is for the outer diameter, and this is for the inner diameter of it.
Yes.
And so how does that work? 'Cause I understand the wheels
2 wheels.
grinding it down, yeah.
And this inside is a cylinder.
Okay.
Oil cylinder, and it pushes the passive pellet into the fixture.
So high force.
Yes.
So
we will
this looks like a jig, right?
Yes.
So you load the heat breaks.
we
in
load
here.
the heat break
Yep.
here, and then the pressure will make the abrasive pellet into the inner hole and to the
Forces
polish.
okay.
Yes.
And are you using then for the abrasive pellets similar materials? It's diamond or it's
Yes.
Yeah. Okay. And this is also, I'm assuming, then pretty high precision. It has to be.
Yes. So the roughness even up to 0.1 micron.
Is that one micron?
0.1.
Oh. Okay. Okay.
0.1.
Okay. 0.1 micron.
Yeah.
Gotcha.
The
Yeah.
roughness.
Yeah. is this one though? It seems like I see these two are running. This one's not. Is this one not needed all the time? Or
Yeah,
okay.
no.
Gotcha.
Mostly we will manufacture in our base.
For the lathes. Okay. So the main thing is now just the outer diameter, getting it from where it's at to a finer tolerance, basically. Yeah. Incredible.
And also we still have the online inspection.
Oh yeah. Okay. So this is
Micrometer.
micrometer. Okay. So this the heat break gets placed in between those 2 points,
Yes.
and it makes sure that the machine is still,
diameter,
yeah,
yes.
it's correct. Okay. And it looks like maybe 3 millimeter.
Yes, 3 millimeter.
Okay. Yeah. Yeah, so I see what you're saying. It looks like a 4 micron tolerance, right?
Yeah.
3.04? Yeah. That's incredible. Yep, there you go.
Yeah.
That's very cool to see. That's awesome. And these look like idlers as well over here?
Yeah.
Okay.
Pulleys either.
Pulleys, yep.
Yeah, for the brushing.
Yep. That's awesome. Lots of them. Do you, for the idlers and pulleys, do you ever, I know that some companies will have motors that have press fit on there. Will you do that, or no? Usually the motor company will take the pulleys or the pulleys, and they'll do the press fitting themselves.
Yeah.
They'll do the press fitting. Okay. So you produce them, send them to them, and then they'll do the press fitting of the final on the motor shaft.
Yes.
Okay. Gotcha.
But sometimes some customer will ask us to assemble for them. Yeah.
Okay. And you can accommodate. Okay. Okay.
We just make the food.
You do it. You're the solution finder, right? If somebody needs something, you'll figure out how to make it happen.
Here, this is the jigs. For the part. Because we, from the online machining,
Yep.
we will move to the cleaning room. So we have the cleaning machine to fix this jigs.
Okay. So this is just storage for now.
Yeah.
Okay. So it seems like it's like for the nozzle, and then for maybe like the heat breaks.
break,
Yeah.
yeah,
Okay.
exactly.
So just different jigs, maybe basically. Is what
But
they are.
the out shape is the same.
Okay, shape is the same.
Yes.
That way for the machine, right? Gotcha. That makes it easier to design for those trays, right?
Yeah.
And these are big machines.
Yeah, it's our CNC machines.
Okay, so there are
Yeah, all the
okay, so you got
So here you can see.
oh, these are like heat blocks, right?
Yeah, it comes.
Okay, so we've got
So
the
it's manufacturing.
yeah. Okay, so it's mostly lathes. You said 40 lathes, but you do still have some big
7 CNC machines. Yeah.
Very large CNC machines.
Yes.
And these are mostly for
For the
heater blocks.
blocks and for some. Yeah, this is for the conch. The conch.
Oh, okay. Heat sink, right?
Yeah.
The heat, okay.
Match thing. Yeah, you can see.
You see that is
The kinematic plate.
kinematic.
For the conch.
Kinematic
Conch
plate.
plate.
And these are also fairly automated. It looks like you
Yes.
got up to 20.
21 tools.
That's awesome. And are these also using the same oil as the other machines for the coolant?
So this is the cutting water.
Cutting water.
Yes.
Okay. Is it special type of water then?
Yes.
Okay.
Yes.
Gotcha. That's awesome. Do you think the plan then, as the product line continues to grow, that maybe you'll need more?
Robot.
Okay.
Yes.
Yeah. You said robot.
Yeah.
And robot, and then also maybe even
Automatic.
more CNC machines,
Yes,
I would
yes.
think, right?
Here we will add some other machines.
A little bit of space, right?
Yes.
A little bit of space. And so,
Yeah, copper. Good block.
yeah, those look really nice.
Yeah.
Yeah, that's awesome. These are awesome machines. So you can, I mean, you have a lot of opportunities to make large parts too if you wanted to.
Yeah.
I'm sure, I mean, that's not really the main thing with the 3D desktop 3D printing or FDM, but you have the capability of doing larger components if you needed to. Yeah.
For some transition parts, for some trays, 3D printing tray, printers.
Oh, you see,
Yeah, we also
out of aluminum maybe for the brakes? Gotcha. And this is all of the materials that you guys are using in this facility.
yeah.
So this is the raw
Our online raw materials.
So we've got
Brass, copper.
aluminum maybe?
This is hardened steel.
Okay.
Yes, this is aluminum.
Aluminum down
Yeah.
there, gotcha. And then these
This is
are
the
also,
aluminum tube
that
for
is,
pulleys, brand.
gotcha. That's nice because you're not having to. I would imagine the machining is faster,
Yes.
and you're not wasting as much material because it's
Exactly.
already hollow cavity right
Yes,
there.
yes.
That's really cool. Lots of different sizes too. But, you know, I'm sure like the heat breaks will need very small sizes, and then as you get further down to some of the larger components, I mean, there's a lot of different sizes here.
Yeah.
Is it difficult to keep track of all this, or?
Of course.
Yeah.
Yeah. Because many types,
Yeah.
different materials, different size.
Uh-huh.
Yeah. So
It's a
we
lot.
need to do the different materials.
Constantly, I would
Yes.
think, yeah. And it goes even further. So you've got even looks like even larger.
Yeah.
Those are huge.
Stainless steel, titanium.
This is how titanium. More looks like maybe copper
Yes.
as well, and some steel as well.
Yes.
And this is for the CNC machine.
Yeah.
Like bar stock. Instead of round, it's square.
It's square,
Yep.
yeah.
Yep. Aluminum and copper, which that's probably what was used to make those heat blocks that we just saw over there, right?
Yes.
Yeah, that's cool. Yeah, that's awesome. Definitely, as a person just making parts for themselves at home, it's difficult to know what you have. I couldn't imagine at this scale, you know, keeping track of inventory and everything like that. So
Yeah.
I'm sure, like with the tooling that you have, all of it needs to be entered into a database somewhere, so that way you can keep track of it. And as things are pulled out, there's an update. You know, okay, we're getting low on this. It's time to order more of these parts.
Yeah.
Yeah. That's very cool.
So this is our main part in the first floor,
Okay.
the manufacturing. And then
Okay.
we will go to the quality control.
Quality control.
Yes.
Okay. We've already seen some quality control though, right?
Yes,
I saw-
this is online inspection. That is controlled by our technician.
Gotcha.
Operator.
Okay, that was in process, and now we're going to go to, after the parts have been made, what the quality control looks like for that.
Yes.
Okay, gotcha. Awesome. This is the actual department for that.
Yes.
So dedicated, IPQC.
Yes.
Yep, in production quality control. Okay.
Yes.
These are so a lot more of the microscopes that we were looking at.
Yeah.
And then, oh, this is cool to see. If they can see that, just to see the nozzle in the microscope.
Yes, the orifice.
Yeah, the orifice of it.
So our technician will do inspection, and the parts they will take from the line.
Yep.
Two parts.
Two
One
parts.
is for the out shape dimensions inspection. So they will inspect the dimensions according to the drawings and write down the value.
Okay. And is this? I mean, I see that she's driving it, but does this program automatically measure, or does she have to basically drag from one end to the other?
Manual.
It's manual. Okay.
But we
Gotcha.
also have the automatic
All
inspection
this
machine.
the future, right?
Yes.
So this one looks a lot.
This is the automatic machine.
Okay.
It can be programmed and can do the section view on many dimensions.
Section view.
Yeah. So it can take a picture from this direction, and all the dimensions will be measured in this program.
Even without having to cut it, it can basically just get that information.
Yes.
Wow. That you said that those were expensive. This one must be very. If it's all automatic like
From
that.
Kins.
It's what?
Kins.
Okay.
Yeah.
Yeah, that's wow. So these ones are manual. This is automatic. Then
Yes.
is this one? As of right now, how do you determine what goes on this special machine? Is it for maybe new parts that haven't been checked so much? That way you can get even more of an assurance that everything inside of it is how you're expecting it to be.
Yeah.
Okay.
Yeah.
Yeah. And then what is this? Looks.
This is a gear engagement instrument. This is for the gears.
Gear engagement.
Yeah, gear
Okay.
engagement.
So this makes sure that the machine
teeth.
has machined the teeth properly, and that there's not like any rough spots or anything that's out of spec, basically.
Yes, good,
Okay.
good engagement of the cheese.
Okay.
Yeah, because cheese transmission, it must be smooth.
Yeah, of course. Otherwise, you're gonna, whether it's extrusion or whether it's pulling a belt, it needs to be consistent all the way around.
Yes.
Okay, so that basically looks. I see. Looking a little bit, there's like teeth on top of it, and then I'm imagining you're probably putting.
The wave.
Okay, so as it's spinning, this is keeping track of how smooth it is. If there's any
Yes.
roughness, it's going to report that on the
Out of
graph.
spec.
Okay.
Yes. Like
And then they'll make a note of something and basically go figure out why that happened on the machine.
Yeah. So once the issue happened, our technician will write down the details and start the machine.
Okay.
And check the parts here.
Okay.
So these are some parts we need to do
Further
judgment.
image.
Yeah.
Sure. Okay. Figure out what happened
Yes.
with the machines. And this is, like, one more time, this is still in production.
Yes.
This is on the line. This is not after the fact when they're done.
No.
This is still, okay, now, awesome.
And here you could see also the roughness. She's doing the roughness
Oh, this is, okay.
inspection.
So this is inner diameter.
Yes.
It looks like it's
For the
a,
roughness.
it looks
The inner
like
hole.
it's a fine pin. Like a pin basically, right?
Yes.
And so how does it determine the smoothness? Basically, as it goes in, if it feels any
Here
roughness,
the surface.
vibrations, like vibrations, right?
Yes. The
Okay.
surface, if there is some wave, and do the signal to the machine CPU.
Gotcha.
And you giving you the number.
Okay, so for the outside, we were doing the microscope right there.
Yes.
And that basically gets a very, very high precision image of it, where they're able to then, with lines, basically see the orifice of the nozzle or the
Yes.
component. And then this one right here is for the inner. So you can use it, this looks like a nozzle, but is this also used for the heat? I mean, anything that's a tube?
Anything.
Yeah, okay.
Anything. Yeah, even we could see. So one part for the out shape diameters.
Yeah.
And another part is for the section cut.
Okay.
To see the inner hole, the roughness, and the angles, and even the orifice.
Is
you could see.
are these, since you're cutting them from, you said one from, or two from a batch roughly, or?
Yeah, 2 for 2 hours.
Okay, okay.
One
It's-
is for the out shape.
Do you
and
have
another is for
to,
the inner hole.
as far as the cutting to get the section like that, is it also an automatic part of the process? You basically just tell the machine, hey, we want one.
Yes.
Okay,
We
gotcha.
want to
And it'll
cut.
just, it
Yes.
just cuts it up. That's very cool. It's not often that you get to see the inside of the nozzle like
Yes.
that, so it's a pretty
Yeah.
cool to see there.
And here, this is our first pieces.
First pieces.
Yes.
So what is first, so,
So for the every new manufacturing, we will have the first piece inspection to ensure the quality is good, and then do the mass production.
Gotcha,
Yeah.
okay.
So, we will take the record.
So it's the same,
part, the section part.
same thing, outside,
Yes.
inside,
Yes.
but you keep track, you keep it.
Yeah, we keep
Okay,
over 5 years.
over 5 years.
Yes.
Oh, wow. What is the reason that you keep it for 5 years?
So that we could keep track of the issue. Once we have the issue, we could take the track of these parts.
And see if there was already an issue initially, or whether,
Yes.
okay, gotcha. Yeah, 5 years is a long time to keep, especially because this is not just Phaetus, this is everything. Like, in any product that you are being asked to produce,
Manufacturer,
yeah,
yes.
then you will keep a initial copy of it, a physical copy for 5 years.
Exactly.
Yeah. Wow. And then it goes at some point to some kind of storage.
Slot, yes.
Okay, yeah, that's cool.
So every day we will update.
Yeah,
To
yeah.
move.
That's also another system that's probably a lot of work to keep track of all of the, right?
Yes.
Time and date and where it's stored. That's awesome. Okay, so that was in production.
In production,
All right.
yes. Yeah.
And now,
And here we will put the preview. Everything. When we finish, we move the parts into the showroom. Yes.
this is to remove that oil or whatever's on the part.
Yes.
So,
So here you can see our parts waiting for cleaning.
okay, so these are the same trays that we saw that either the technician was manually placing on there, or the robot arm was placing it on these trays here.
Yes.
Okay.
Yes. And so here you can see this is our cleaning machines.
So this is a room.
Yeah.
An entire room for cleaning then. Wow. Okay.
This is the entrance.
Okay, so you've got like not a belt system, but like wheels that roll
Yes.
it in. So you put the plate here.
The basket
Yep.
we put it here,
Okay.
and it will enter into the cleaner.
Okay.
And there's the robot here.
Oh yeah,
This
big
is
robot. Wow.
Yeah. We have three.
Wow.
Yeah.
Okay.
3 cubics inside the roughness cleaning.
Yep.
The detail cleaning.
Yep.
And the
drying.
Okay, so you do a kind of a quicker clean, a more detailed clean, and then finally dry off the parts to make
Yes.
sure there's nothing left on them.
Yes.
And then what is, as far as the process inside there, it's ultrasonic clean, or what's the method of cleaning?
It's ultrasonic and also with the vacuum.
Ultrasonic and a vacuum inside
Yeah,
there.
because the nozzle orifice is too small to clean.
Okay.
So with the vacuum, the liquid get into the
So the vacuum just sucks everything off of
Yes.
it, like anything that's on there, it's not supposed to be on there.
Yeah.
And then it comes out through here.
yeah.
And I imagine that just about everything has to go through this process.
Yes.
This is a very important
Yes.
machine, right? Yeah. And then once they're done there, they're basically ready for the next step, like the
Next step.
Okay.
FQC.
Okay. And what, for just out of curiosity, how long, like if you a batch of parts that looks like it's maybe 3 or 4 trays?
It depends. It depends. So if the parts are bigger,
Yeah.
then the time will be longer.
Okay.
Mostly it's about 12 to 15 minutes
So is it
for one round.
Okay.
Yeah.
And
Outside.
that could be multiple multiple.
Yeah, multiple.
Okay, plates. Yeah,
Plates,
that's what we call them. Gotcha. Yeah, this is this is a serious cleaning room. And this is up top is the I'm assuming vacuum related.
No, this is for the environment protection.
Environment protection.
Yes.
Okay. Gotcha.
Our government required.
Okay. Yeah, that's incredible. And then these I saw when we were walking in. These down here.
This has been cleaned.
Okay.
Yeah.
So these ones, at least the shiny ones, you can
Yes.
tell the aluminum on them is really shiny.
Yes.
Okay, so that's what's the cleaning, man?
It's so the last
Like,
in this floor.
finished QC is what it is? FQC?
Yeah,
Okay.
finished QC.
Okay, so this is no, this is not during production. This is after.
Yes.
And this room looks similar to the
To the-
previous room.
yeah,
So same sort
Same
of
inspection.
Yep, microscopes over there. I see some gauges over there as well.
Yes.
Is roughness ever needed to test in here, or usually not so much in this room?
We do the inspection according to AQL 65.
Okay.
Yeah, mostly for the critical parts.
Okay.
We do the 20% inspection. For the general parts, we do the 10% inspection.
Okay, so 20% for the
Critical
critical
packages.
component dimensions,
Yes.
and then 10% of non-critical dimensions.
Yes.
And that's for every.
Every batch.
Wow. I can imagine it could be a long process then, right? I mean, it has to be 20% of them, especially if it's, a process like that.
Yeah.
And then, so we have one over there, and then this is.
Here, yeah, this is debris removal.
Debris
And,
removal.
Yeah, and the cleaning of the copper parts because it's easy to oxidation.
Okay.
Yes.
Also, I imagine with scratching probably too, right? You want to be, that's why a very careful, delicate process
Yes.
with the paper.
Yes.
Wow. So there's a lot of QC happening down here.
Yes.
Now between and you've got engineers, you've got
Online.
yep.
And then in production.
production,
And
and then
then-
finally FQC.
Yes.
That's awesome. I mean, it's necessary. Like the components we're using for 3D printers, like if something's out of spec, it can be a horrible experience, right? Like it's not going to work the way you'd expected. So it's nice to see though the level of kind of detail that goes into ensuring the consistency of the diameter of all of the parts. So
Yeah.
that's awesome. Okay, so we've seen.
So this is our first floor. For the manufacturing and quality control.
Okay, yes. And then showroom as well is right over there.
Yeah.
Right, a little bit of the showroom.
So next we will go upstairs for our assembly workshop. Yeah. So here we take the giveaway.
Yeah. So we're gonna do a giveaway, the giveaways now. So the way we're gonna do the giveaways is wait 1 second. While you're in chat, we want you to type Phaetus in chat. And we're going to have somebody basically take some pictures, and I'm going to read off the winners right now. So if you're in chat, type Phaetus, and we will end up, we'll have you contact Phaetus after. So just type Phaetus in chat. We're going to do some giveaways right now. And for the giveaways, are we doing the new
products,
Okay.
yes.
And is it the winner can pick, like if they want a nozzle versus a punch, or how are we doing that? Or is it random?
Random.
Random, okay, okay. So it's going to be for the new product. So nozzle,
The anode nozzle, the silicon carbide nozzle for brachy and pusher, and the Apple version 2, and even the couch button.
Okay, so the giveaway is going to be, we're 5, right? I think 5?
Yeah,
So
five
5
items.
items, yep.
Five
It's going to be silicon carbide or end coat for either the Prusa or the Ender Reality printers. Or Phaetus 2 is going to be another one we're doing. And then we're also Conch, which is going to be the hot end for the Bamboo Lab P series as well as the X series. Exactly. So all you have to do to enter is type Phaetus in internet.
Okay.
It's okay. Okay, I'm gonna read the giveaway winners again. So we have Man of the Croc, you are the first winner. Bill Morris, you are the second winner. Nathan Chu, CHIU, you are the third winner. It looks like the same. We're gonna do one more screen grab because it's the same winner twice, and then we'll do Lord Gitface, you are the fourth winner. We have a double winner, and so we're going to redo one more. So Delmar, you are the fifth winner. So we've got Delmar, Lord Gitface, Bill Morris, Nathan Chu, and Man of the Croc. Those are our first 5 winners. So congratulations. And then because of the way we're doing this, just reach out to Phaetus at either marketing@phaetus.com or on Twitter, whichever is preferred, and then marketing department will make sure that they get your information and get you the prizes. So congratulations, and then we will also be doing another round of giveaways a little bit later on. So awesome. And then we are going to be going upstairs, and we did test this. We did test this yesterday, and we lost signal for just a brief moment. So if the signal cuts out as we go upstairs, don't panic. It is expected, and it'll reconnect as soon as we get upstairs. So let's do it. Awesome. So we're going to the assembly.
The third.
Assembly room.
Yes.
Yes. Okay. Still working? Yeah.
所以说先卡住。
Still waiting.
Okay.
It's okay. Okay. It's, we are back live. We just had a little bit of wireless connectivity. So this is the third floor now, which is the assembly workshop.
Yes.
Okay. Awesome. Let's take a look at it.
Yeah.
So this is a bit more peaceful and quiet than the downstairs room. It also looks like there's a lot more space up here, which is nice.
Yes.
So this-
mostly this is our Phaetus products simply line.
Okay, well downstairs is everything. This is Phaetus mostly for the assembly.
Yes.
And what products are being assembled up here? So,
This is for Apple's version 2.
okay, so Apis 2, the new extruder.
Yes.
How long is the process of assembling one of these approximately?
Perhaps 2 or 3 minutes. So long is it?
2 or 3?
Yes.
So very fast. Can we possibly see?
Yeah, we can have seen.
Okay.
So we can see from here the first step.
So I imagine it's the drill is set to a specific torque spec,
Yeah.
right? That way it's not too
Yes.
tight as you're tightening on. So we've got the little motors. Yep.
Yes.
So that's the
And the
housing on
third
the motor.
machine.
Then this side is looks like tension arm goes on. This
Yes.
is the electronics. So you've got the filament runout sensor.
Runout sensor,
It's
yes.
going on there,
Yes.
and that goes onto the other body.
Yeah. And here is our final inspection.
Okay.
Yeah.
So this is checking to make sure that it was assembled correctly then.
Yes.
And this I see a multimeter. So you were testing the electrical on it?
Yes. To see if any broken.
Oh, this is good. There's especially if it's a filament runout sensor, there's probably nothing
Yes.
worse than
Yes.
figuring out as you're using it that there's an issue. So each of the switches for the filament runout are tested then on every single unit.
Yes.
And then from there, once they're completed, they'll go
They will
into
to
their
the package.
nice boxes, then get shipped off. That's awesome.
Yeah.
So it's so each person has their own specific part of it that they do.
Yes.
Yeah.
And based on the SOPs.
Oh, and even up top, there's the specifics about sort of the assembly process, right? So that way, if there's ever someone that needs to reference it, they can quickly see it.
Yeah.
This is cool. And so I know that you have, like for some of the other hot ends and other products, some of those are at least partially assembled as well. So for those ones, would those also be assembled somewhere on this floor?
Yeah.
Okay.
Of course. Yeah, we will do the pre-assemble.
Pre-assembled,
Yes.
okay, yeah. So it's just depending on what products are needed at the
Yeah.
time, that's how you sort of determine what the assembly line is going to be for the current time?
Yes.
Okay, gotcha. Yeah, they're very...
So here we go to the right to see the unique nozzle assembly.
It's a lot of extruders.
Yeah.
It's a lot of extruders there. I mean, 14, 16, 18, 20, 40, 60, I mean, maybe 80 or so extruders being
Yes.
assembled right now?
Yes.
That's awesome. And this is another part of the assembly?
Yes.
Okay. So this is the other part of the assembly. What is this room? I mean, it's assembly, obviously, so it's same floor, but what is being assembled in this room? I see presses.
Yeah, pressure.
So this is for...
This is for the unique nozzle.
Okay. So unicorn nozzles go here. And this is a...
For reality.
Yep, okay, so this is the press. So we've got... Oh, this is for the
Silicon tip.
Silicon tip. of it.
Silicon
Okay,
carbide
so
tip, yes.
so it gets placed inside of that metal, which I'm assuming is a like a jig to ensure that it's seated
Yes.
properly, and then this is set to a specific
The pressure and
depth.
the stroke.
Okay, gotcha. And then wow, so it's semi-automated then, in a sense. So
Yeah.
it has to be placed, but the machine does the rest of it for you.
Yes.
Yeah,
We have the pressure measurement during the assemble.
Yeah, these look really, really nice. These are, you said the Creality silicone carbide.
Yes.
Yeah, so you've got the copper
Copper
outer
nozzle body
yep.
and the silicon carbide
So
chip.
really high thermal transfer, which is good for melting the material.
Yeah.
And then you have the tip of it, which is going to be very high abrasion resistance.
Yeah.
And those nozzles also are higher flow, aren't they? Like they're higher output?
Higher flow.
Yeah, high flow.
Yeah.
That's awesome.
And much more abrasive.
Much more abrasive,
Yes.
yeah. That's cool. And then this up here, just for, it's kind of interesting to see. Is that up there basically just where it says the distance it's traveling in the force? It looks like the force
Yeah.
it's applying.
Yes.
So I see, I mean, hundreds of kilograms, it looks like, right? Or, no, yeah, hundreds of kilograms.
Yeah. 400.
400 kilograms. So it's a lot of force being applied.
392.
Yeah, that's awesome. Which, I mean, I've always wondered, it makes sense to me when you have a nozzle that's all the same material, but when you have an insert like that, you have to be really forcing it in there to mate properly. Otherwise, I mean, with the pressure that you're extruding filament with, if it's not seated like that, you're gonna have issues, right?
Yes.
The nozzle's gonna pop out, so yeah, that's very cool. So it's a press.
Plus the nozzle will heat up during printing. So
Yep.
it's high temperature, even up to 350, right? So the brass
Looks-
copper will be expanding.
Oh, wow.
So it's very important to make the sealing.
That's a good point. It's not even just a matter of getting it to be in there strong. As it's heating up and it expands, so there's
It's
got to be
easy to be leak.
So there's got to be a sweet spot where you find, in the heat, basically from like low heat to high heat. What's the sweet spot for getting it to stay in there forcefully, right?
Yes.
And then this over here looks like it's
Engraving.
labeling. Okay.
Yes.
So these are fiber. I recognize the lasers. So fiber lasers, and these are adding the details about the nozzle. So like
Yeah,
the
information.
diameter
Yes.
and what exactly they are.
Yes.
And then this is more QC.
Yeah.
This is
This is for the, so during our assembly, we still have the inline
Yep.
quality control.
okay.
Yeah.
So these look like conch, right? This is
Yes.
what this, yeah.
Conch content.
Gotcha. So she's going in with the digital calipers, which I recognize, I'm familiar with, and just verifying that they are where they're supposed to be within tolerances.
Inspect,
Yes. And I don't think I got to ask was I didn't see anodizing downstairs for the heat sinks. So the process, I saw the heat sinks in the raw aluminum material.
Yes.
But how are they getting the
Manufactured.
the anodizing process.
So we manufacture it in-house and then we send out to our supplier.
Okay.
Anodized.
Okay, gotcha.
So
So you machine it
one
in-house and they can anodize it very effectively to whatever
Yes.
color you guys decide. And then so she's checking after the fact, I imagine also that the anodization was correct as well, because otherwise it will be out of spec basically.
Yes.
So that's awesome.
Yeah.
Yeah.
And also during our assembly, we will do the online printing test to ensure the quality
Gotcha. Okay.
without any issue.
So this is after all the downstairs testing.
Yes.
And after it's gone through any post-processing,
Yes.
then it's still getting tested.
The final
Final
product.
product. Okay. And this is, I mean, I imagine you can't test everything. So is it one per batch, or how is it determined?
Yeah, one per batch.
One per batch. Okay, gotcha. Which, after all the testing that was done downstairs, you would assume that it's probably okay if the one
Yes.
turns out to be This is like kind of looks like my garage a little bit actually, with all the different printers in it. So we've got
Our order machines.
Enders, Ender, I don't know this one, but another Crowley Elegoo. I recognize the
Boron,
Boron, yeah,
yes.
2.4, Ender 7, and then looks like
The older one.
yeah, it almost looks like the old
The Delta.
yeah, exactly, Delta printers,
Yes.
which are a lot of fun. So. And then even a Prusa printer up
Yes.
here for some testing, which makes sense because you guys have the Prusa nozzle now.
Yes.
So you do need to verify that with the machine. And then of course a bamboo printer. So
So this is on testing now.
okay.
Yeah. So every batch we will take one part
Yep.
for assembly to the machine for the properties
Okay.
test.
So the conch hot end will go get installed in a new machine, and then you'll
Yes.
run one of various test prints on there. And this is more of a just quality check to make sure that the part looks good. And if it doesn't look good, then it could be that. It could also be, I guess, maybe the filament. But like it lets you know, like it should turn out a specific way.
Yes.
Yeah. And for these models, I mean, I recognize, of course, the Benchy.
Yes.
And I see some other here. Does it change the model? Just
Yeah,
kind of-
sometimes we have two test models.
Okay.
This is standard model,
Yep.
and also the test bench is also the standard model.
Yeah, so this one is, I'm familiar with this one. Retractions, you've got overhangs, you've got more overhangs, you've got bridging.
Yes.
And then this is also usually to check like cylinders, how well it does cylinders on there.
Yeah.
Yeah, these are cool. And for the testing on this, are you using abrasive or material, or no, there's just basic like PLA just to make sure?
PLA and also some abrasive materials.
Okay, so it
Yeah.
just depends sometimes, gotcha.
Yes.
But this is, I mean, again, this is just a final check. Like this is really, I imagine that there can't be very much that makes it through all of the other QC gets here, and then you're like, there's a big, like most of it must get caught downstairs.
Yes.
Yeah, so this is cool. I mean, this is reminds me of like where I would want to hang out, like in the lab with
Yes.
some of the printers and stuff.
Yes.
So cool. So this is the final room up here for now.
For assembly test.
Okay, for assembly and testing. And then
Next we will go to the warehouse.
okay, so after everything's in here, they're put in boxes and they have to
And
go
goes
somewhere.
into the
They have to go
warehouse.
okay, so we're gonna go to the warehouse. There could be some issue again with the signal when we go downstairs, so everybody hang tight just for a minute, okay?
In warehouse, so we walk from stairs.
Oh, stairs for this one? Okay.
开上。
See if the stairs will work.
开下这个。
Get our exercise in just a little bit. Huh?
Take care. Any signal?
No?
个安那个电梯柔性。
赶紧开门。2楼，这个电梯这里，快点，过去。
Yeah.
Is it go? Yep. Okay, there we go. All right, there we go. We got in. So this is the warehouse.
Yes.
So this is the final section, final part of it. Okay.
But before we go to the warehouse, firstly we do the appearance inspection here. Another inspection.
More inspection.
Yes.
This when you say appearance inspections, this is visual. Make sure that things
Yeah.
look pretty as you would expect before they go out to the customer. So this is mostly, I would think, like polishing, or what's the?
Just the appearance of the part.
Okay.
To see if any damage or scratch.
Gotcha. Okay. You want to make sure they look fresh off the machines when they go
Yes.
out. Yeah.
One by one.
Checking. Wow. So just checking each and every single one, and those are all the heat breaks still.
The tube.
The tubes, yeah.
Yes. This is also the tube.
The tubes, yeah.
Yes. This is the nozzle body. Yes. And this is the heat block here.
Which one? What is this one? The heater block.
Yes.
Okay, so this one, she is checking
Checking the appearance and also the
thread.
Yes.
Yeah, to make sure it's nice and smooth.
Yes.
So she has the basically the same thread that would be on the heat break going into there.
Yes.
And just verifying that there's no binding or any issues with each of them.
Exactly.
And this is done a couple per batch, or is this every single?
Everything.
Every single
Yes.
one. Oh, okay. So
Okay.
this is a long process.
Yes.
Yeah. Wow. There's a lot more testing than
Yes.
I could have imagined that
Yes.
goes into making even a hot end or a nozzle or something like that. That's
Yes.
incredible. What is this machine over here in the corner?
This is a salt spray machine. Salt spray.
Sort spray. Okay.
Yeah. Some part we need to do coating. So
Like the
to-
next coat.
yes.
Yeah. Okay.
Yes, to prevent rust. So this machine just to measure how the coated
Gotcha.
protected.
So this induced rusting.
Yes.
Yeah. Okay. And it looks. Is it salt? I mean, it's salt.
Yeah.
Yeah. Okay.
Yes.
Yeah. I mean, I've seen long story, but I've seen what salt can do to metal. So this you will take some of the coated parts, put them in here, run it through this, and this will quickly let you see if you see rusting, then clearly the coating wasn't applied correctly.
Yes.
You need to go back and either recoat it or figure out what happened. And but you hopefully you put something in here, you run it through the test, and there's no rusting on it at all. And It's
Yes.
good to go then. Yeah, that's a very important thing. If you're coating something, you want to make sure it's coated
Yes.
properly. So, and how long, if you put a nozzle in here, how long until you will know if it's?
It depends. So
Okay.
for some coating we should take about 4 hours, and
4
for
hours.
some coating we need about 12 hours.
Oh wow, okay.
Yes.
So it is faster than just leaving it out, but it's still
Yes.
it's time-consuming process.
Yeah, it's a high speed.
Okay, yeah. But 4 to 12 hour range, those still take some time. So
Yes.
this is a situation where it's also like one from each batch then?
Yes.
Okay, yeah, because it'd be impossible to do
Yes.
everything through that. That's awesome. Okay, so basically a rust testing machine is what that is.
Yeah. So after the appearance inspection, then we will move to the warehouse.
Okay, so this is
For package.
packaging, finally, it's the packaging. So things will go from appearance, they'll go into this room. This is where things will go into boxes as well, like the
Yes.
small boxes for nozzles.
Yes.
And this, okay, so she's packaging up, it looks like.
No. She's also do the quality control, do the inspection.
More inspection?
Yes.
Even after they've just been inspected?
Yeah, OQC, our outgoing quality control.
Outgoing QC,
Yes.
okay. So this is mostly visual inspection as well then?
Yes.
Okay.
And
But there is also
with the dimensions
another one of our
inspection.
microscopes. Yeah. So if there's something that raises concern, the technician or the person can then take that over there
Yes.
and see was there actually a reason to be concerned, and if so, then we go back down the chain until we figure out what
Yes.
happened. But hopefully it's not needed very often because after, we've gone through so many different stages to get to here, it should be really, really nice and just look over it.
Yeah.
And also looks like checking against maybe the drawings as well, one more time to verify?
Yes.
Yeah,
So after that, then do the package.
okay. Packaging is done over
This table.
this area. I recognize I liked all the stickers, yeah, big fan of all the stickers. So this is the packaging table then, and then it goes from packaging
And
over
move to the shelf.
To the shelves.
Yes.
Gates?
Yeah, yes,
I recognize Gates, but you are not Gates, you are a distributor of Gates?
yes.
Okay.
We are the biggest distributor for gas in 3D printing.
Wow, okay. And so, these are huge boxes, so with these, are you packaging them up into different packages or?
Before the packaging, we do the cutting.
Cutting,
The
okay.
belts cutting.
Gotcha.
So, based on customer requirement.
Okay,
So different lengths,
sure,
different.
yeah,
widths.
depending on the printer. I mean,
Yes.
some printers, if it's a small, like Boron Zero, it's a small belt. If it's a big 350 millimeter, it
Yes.
takes a lot more. Okay, so these come big rolls of them, and then you're basically cutting them down and packaging them for
Yes.
specifications then.
Yeah.
That's I could use one of these boxes, of belts. You can never have enough belts. Okay, and then this is the finished
Yeah,
stuff.
finished with the products.
So these are some of the products that we've seen. Dragon Ultra High Flow, we got Boron,
Rapido.
Rapido
Tai
2. This is the co-print, it looks like down
Yeah.
there on the ground. I recognize that Dragonfly, the Tai Chi you said, and then, oh yeah, even Drop Effect.
Yeah.
So these are,
Drop.
yep, Omnia Drops. This,
Version 3.
Version 3, okay.
Yes.
I think version 1 is the one that I tested a long time ago, so
Oh, really?
now version 3, it's come a long way since then. And so one thing I'm noticing is like, you've got Rapido
Rapido
2,
2,
Rapido 2,
Rapido
Rapido 2,
Yeah.
kind of all over the place. Is there a reason for kind of not having all the same things?
Actually, we put it in different place because of the different manufacturing date. So we will do the first in, first out.
Gotcha,
So
okay.
we put in the
So
old
this-
one in the
yeah,
outside,
okay.
the new one in the inside.
So you said first in, first out. So this
Yes.
would be something produced earlier. This is like newer produced.
Yes.
Gotcha. So each one of these represents like one production run of that component.
Yes.
Okay, that makes a lot of sense then. So, yeah, this is awesome. It's incredible to see. I'm so used to. This is what I see usually, right? Is the finished product that comes
Yes.
out of the box and goes into the printer. So to see how it goes from the raw material to all
The
through the
final
testing,
part.
through the cleaning, through everything. Yeah, it's
Yeah.
incredible. And I love the whoever does the design. Yeah, it's really nice. I mean, they're all very unique and
Yeah, we
just,
design ourselves and send to our supplier. for
Gotcha.
Packaging maker.
yeah, I really like. I mean, the Phaetus too. It's like a holographic. It's really nice. So cool. So we've seen the manufacturing.
Yes.
We've seen the
Assembly,
cleaning,
yeah.
QC, assembly, and then the
Package.
packaging and the warehouse.
Warehouse, yes.
So what is next?
Next, we will back to the front desk
Okay.
to see how it's printing of
Okay.
our new products.
New products. Okay, so we're gonna head back to the main showroom
Yes.
and take a look at the printers and see how the
Yes.
prints have been going.
Yes.
Okay, awesome.
Okay.
I will let you lead the way.
Okay.
Seriously, yeah. It's a nice day. Yeah, nice day. Might as well enjoy the day.
Awesome. Excellent.
Yeah. It was a long flight, so I didn't get so much exercise. So this is making up for that, you know.
Yes.
Yeah, this has been incredible, though. It's a big operation. It's a very big operation. The 40 lathes and
7 CNC machines.
and then a couple additional post-processing machines for grinding and for
Aggressive.
integration. Back in the production room. What is the size of this?
Here is about 8,000 square meters.
8,000 square
Yeah.
meters. Okay.
Each floor we have 2,000 square meters.
Okay.
So we have 4 floors.
This is. I mean, the whole building is
All around.
yeah. Okay.
The first floor is our manufacturing workshop. The second floor is our warehouse. The third floor is our assembly workshop.
Okay.
And the fourth floor is our office.
Okay. Like sales and support
Engineering,
and
sales.
engineering. Yeah. I think you had mentioned earlier how much of all production that is done by Runis or Phaetus is done here.
Yes, mostly.
Mostly.
Yeah, 90%.
90%. Okay.
For other 10%, we need to send ours.
Gotcha. That's like when you mentioned things like
Coating.
yes. Oh yeah. Yep. Okay.
And dyes.
Gotcha. Everything. I mean, everything else is done here in this facility.
Yes.
Yeah. It's incredible. Yeah. It's huge. You said 150 people approximately working for the company. Yeah.
Yes.
Yeah. I think for a lot of people, it's one of the first times to see the inside of the factory like that.
Yeah, yes.
So especially at such a large scale, like it's incredible. I mean,
Yeah.
it's just lots of organization, lots of systems in place.
Machines.
Lots of machine. Very loud in there. It feels nice though because it's kind of a cooler day. It feels nice inside there. But so this is back at where it all started, right?
Yeah.
So we've got our finish done, yeah. This little flexi jack. Oh, look, can I? Yeah. That looks glass filled.
Yes.
Yeah, it is. Huh? That's not
Yes.
like a PLA. I can see by the color on it that that's not a PLA. That's an abrasive. So this was printed with conch. See?
Yeah, conch. Conch harden.
Little flexi rexy. Everyone, I feel like most people are familiar with the little flexi rexy dragon. That's cool. And then the other one was printed with the unicorn nozzle.
Yeah,
right?
unicorn silicon carbide nozzle.
And this was PET glass fiber on both of them? I think so.
Yeah, PET,
yeah, okay.
PET glass fiber, yes.
You can hold yours up too? Yeah, that's cool.
Yes.
Those turned out really nice. I mean, a lot of people really like printing with the filaments that are abrasive, even just, not even for functional always, but just because the parts turn out so nice. I mean, they almost look injection molded with the texture. It sort of blends all the layer lines together into sort of a singular piece. That's awesome.
Cool.
So, do we want to do another round of giveaways now?
Yes.
Yeah? We want to do another round?
Exciting time.
Exciting time, yeah. Everybody likes it. Anyway,
Yes.
so we're going to do the same thing again. So, if you are in chat and you are watching, type Phaetus, and then we're going to basically do 5 screen grabs, and I'm going to read off the winner for those. So, just type Phaetus in chat, and then we will pick the winners in just a moment here. I think we'll do no duplicates, so 10 unique winners.
Yeah.
Yeah, that's best. Yeah, so we'll do 10 unique winners. That way, more people have a chance to win one of the new products. And then after that, I think the plan is that we're going to do a little bit of questions and answers,
Yes, of
right?
course.
Okay. So the game plan is we've seen the facility. We've seen the startup with the showroom, went through manufacturing, we went through QC, we've assembly, warehouse. So we've seen everything. So the game plan is now we'll do some giveaways and then we'll open it up for any questions. So if anybody was watching and has some additional questions, either for myself or for Donald, then they can ask and we'll do our best to answer those questions.
Yeah.
So, okay. So the first winner is, we'll do Petty Ruxpin, P-E-T-T-Y Ruxpin, R-U-X-P-I-N. So that's the first winner. Second winner is Kui Deng, C-U-I-E-D-E-N-G. Third winner is Clown Hammer, Kleinhammer, you are the third winner. Fourth winner is Jose Rivera, Rivera, Jose Rivera. And the final winner is Troy J. Troy J, that is the final winner. So congratulations, and I'll mention again that because of the way we're doing this, reach out to Phaetus either via marketing@phaetus.com or congratulations, or if you're on Twitter, you can also reach out via Twitter, was fine to marketing as well. So congratulations, and then they'll figure out the shipping as well as who won exactly what, because it's going to be a variety of between like Conch and Apis 2 and the Crucio slash
Yes.
oh yeah, and using Encode as well. So okay, so I think we'll maybe open the floor up to some questions then. I don't know if it's best for us to just read the questions off of the stream, or if you want to pick some questions.
没有问题。他们问我们有多少人？
See?
问我们有多少人？刚刚上面。
Okay, so there's some delay. There we go. So let's see. They said, Modbot, can they send us a hoodie? I just got this hoodie right before the stream, and I don't think they're sending any hoodies out, but I do really like the hoodies. So sorry, Phil. You can ask, but I don't think so. Modbot, can they send? Oh, they're asking if the winner wants a hoodie. Could they ask for that?
Yes, I think.
Yeah.
Yes.
Okay. Yeah. If whoever won wants a hoodie, if you want to ask for a hoodie instead, it seems like that's fine. Yeah, then that's fine. We can do that. Yeah, it's a very very nice hoodie. So, someone's asking, what would you say is your best extruder for a Voron Zero? Well, I think that based off of the Voron Zero being very compact, that probably Apis 2 would be the best for it, because very compact. We can show the extruder. So for anyone not familiar, Apis 1 was much larger, a little bit triangular in shape almost.
Yes, the first one.
So Apis 2 is a lot smaller and a lot lighter, so I think that it probably makes the most sense for a V0 if you're looking at extruders.
Yes, with some adapters.
Yeah, there's on the bottom here, you've got basically threads already baked in, so it should be pretty easy. If the printed part doesn't already exist, it should be fairly simple to adapt it for Apis 2. So, and I have one of these at home, so maybe if I start playing around with it, I can make some kind of a simple plate for it.
Yes.
So, let's see, what would you say, Apis 2? You guys are awesome. It's really, everyone's saying thank you for being so gracious and for allowing us to do everything in the giveaways. And also, they said that our pleasures, thank you. Someone's asking, any thoughts for an Apis 2 that would be compatible with the Creality K1?
It depends. Actually, Reality K1 is a closed line of the extruder and the hot ends.
Yeah.
So for Apis 2, it's difficult to replace directly.
It would have to be a custom solution, I think, right? Yeah, because I know that I've replaced the extruder on the Creality K1, and the mounting points are also on the side of the unit instead of the bottom, and it's a little bit tricky. So I think that maybe it's a possibility, or perhaps,
We need to double check.
Yeah. Okay. I think though I've seen some people that have taken. I should be looking over here. I've seen some people that have been taking the Creality K1 and have basically made sort of a riser plate for it, and that allows you to use other extruders. But it wouldn't be like direct swap into the same housing. It would require some kind of like an interfacing plate to make them mate with each other.
Yes.
So. Someone's asking, is the end coat technology like some kind of improved DLC coating?
No, actually totally different.
Totally different.
DLC coating.
Okay.
It's a kind of another nano coating.
It's a type of nano coating.
Yeah, because for the end coat, we could coat inside.
Yep.
But for DLC coating, just outside.
That's interesting.
Yeah.
So, wow, okay, so you're saying it coats both inside and outside?
Of course, for the end coat.
Okay.
But for
it's not
normal
possible.
DLC coating, just outside.
Is the reason that you can't coat the inside with the other one is because of tolerance issues? If you soak it on the inside, it will basically, it'll be a problem, or what?
It's kind of coating process.
Okay.
Yeah. So even we have 0.1, 0.2 surface, we could also do the internal
Wow.
surface.
So it's very fine. I mean, very, very fine coating then.
Yeah.
And then as far as the hardness or the wear resistance between end coat and the you said DD.
DLC.
Yeah.
or hardened steel.
How's comparison between the two?
Based on our test, at least 2.5 times more.
Okay.
Yeah,
So
for the abrasive.
Okay. So 2.5 is 2.4, 2.5 times.
Yeah,
more
times
more wear resistant. Then. Okay. Let's see. Someone's also asking, will Phaetus be making hot ends for the Bamboo A1 series?
Yeah, we have some upgrade.
Okay, so we have confirmation here that it is coming. I think that everybody is excited because Punch is now available for these. But there's a lot of people that also have the smaller A1 Mini
yes.
or A1. So you heard it here. It is coming. There will be an upgrade option available at some point for the A series, which is incredible. Let's see. Any other questions here? That's why they can. So this person's saying, oh, that's how they're able to make the coating in the heat break because it's so fine, it doesn't cause issues inside of it.
Also, it's the same theory to make the end coat inside the heat break as the nozzle.
Gotcha. But it can't be done with the older coating, right? You're saying also it's on the outside.
Yeah.
Okay. Yep. Let's see. Someone's asking if I'm getting some tourist time as well. Yes, I think we will go to dinner later today as well. The facility says the facility is fascinating. How much time does the entire process for a batch of nozzles take? Oh, that's a tough one. So someone's asking for a batch of nozzles. Let's assume those trays that you have, the cleaning trays.
Yes.
Those hold approximately 100 nozzles. How many?
250 for 1 jig.
Okay, so 250 on 1 jig.
Yeah.
And I know that, of course, the manufacturing time will probably differ, whether it's copper versus hardened versus, and then also whether it needs to have a nozzle pressed inside of it.
Yes.
But let's say if you're manufacturing a standard, let's just go like a copper nozzle with nothing additional about it. How long will it take from the time it's created to go through and make 250 of them, and basically get them to the stage where they're ready to be shipped out? If you had to guess.
In the manufacturing, our lead time is one day, one shift.
Okay.
And then in no more than 2 days, we will go to the warehouse.
Okay.
Yeah, so totally 3 days.
Okay, gotcha. But I imagine that the nozzles, the actual machining of the nozzles is quicker, but that's for the entire process.
Yes.
Yeah. Okay. So they're saying one day lead time typically, and then 2 day to get it like
For
from beginning.
inspection, cleaning,
Yeah.
inspection,
Through the rest of the
and
processes.
packaging.
Okay. Yep. Let's see. The process. They have a lot of quality control. Yes, they have a lot of quality control in the manufacturing process. That is something that absolutely surprised me. I of course I know that there has to be some sort of quality control, but just the sheer amount of stages during, after again, like it is incredible. So let's see. How about they're saying, how about a nozzle for the V0? I have a Dragon on it. Well, based off what I'm going to make a recommendation. So based off what I've seen here, if you have the Dragon hot end, the new end coat nozzles seem awesome. I know that the inserts are high flow. Are these also high flow?
Actually, this is standard flow.
Standard flow.
Yeah, but for Dragon hot end, the standard flow and the high flow, this is also the same.
Okay.
Same nozzle.
Okay. Will there be diamond silicone versions of these ones, or not planned right now?
Yeah, we have the plan.
Okay.
Yeah, we have
Gotcha.
the plan. Yeah.
And those ones, if it has the insert, would have the higher flow, I would think, on the actual insert, right?
Yes.
Yeah. Okay. So my recommendation is if you can find the silicone carbide version of it.
Yes.
Yeah, that would be, especially if you're printing with a lot of abrasives. If you're not printing with a lot of abrasives, then I think that the end coat would be a great option
Yes.
for.
But one more notice.
Yep.
For the Dragon hot end, because the heat break tube is too thin. So if you want to print with the carbon fiber or glass fiber elements, please remember to upgrade of the heat break unit.
Okay.
Yeah, heat break unit should be also upgrade.
Interesting. Okay. So the heat break, if somebody has a Dragon hot end and wants to print with a lot of abrasives, they have the stock heat break, can they get the replacement heat break from you guys?
Of course.
Okay.
We have this upgrade.
Okay.
Heat break for Dragon hot end for composite fiber filaments.
Awesome. I didn't even know that. So okay. So yeah, I would say the if you can get the silicone carbide, they look incredible. But if you don't need that much abrasion printing, then Encoat is going to be a really solid option. But if you're doing a lot of abrasive printing, make sure that you upgrade the heat break, is what I'm being told here. So when in the stream are we going to talk? Somebody's asking when in the stream are we going to talk about food, because on my streams we talk 3D printing and then 3 hours in I'm like, oh, I'm so hungry, and we start talking about food. Oh yeah, I've been wondering about food this entire time. Thank you, Conchanikas too. Thank you. Yeah, everybody is saying thank you. Hey, P3D's here as well. So I think that probably is it as far as the. I think that's it as far as the questions go. So I will pass the phone back to over here for now. So I think that will conclude the stream. I did want to say also that I have gathered some additional footage myself, and so when I get back to the States, I will kind of compile that into a video that will sort of complement this as well. So maybe I'll have some clips that you weren't able to see from the live stream. So as soon as that is available, it'll probably be next Saturday, I will let everybody know. So it's still working? Okay, we're still good. Okay. Yeah, I think that concludes it, right?
Yes.
It has been an absolute pleasure. Thank you so much for getting me out here. It was not a simple task, I think, to get us all the way out to your factory and then just showing us the ins and outs, because I've been 3D printing for 10 years and I've worked in the industry a bit, but I've never ever seen anything like what you guys have here at your facility. So I think that we're all very excited. Coming from someone that builds a lot of DIY or kit 3D printers, Rapido and just Phaetus' products in general have always been a very highly recommended ones. I think all of us are excited for the new generation of products, as well as future, the 2027 and beyond. We're all very excited for it. So yeah. But thank you everybody also for tuning in, and I know that the timing is different than I normally stream at a different time, so thank you everybody.
Thank you.
And yeah.
Thank you, and it's our pleasure to introduce our factory to our fans.
Yeah.
Yes.
A lot of fans out there, so I think that this was a very awesome opportunity to show them behind the scenes.
Yeah.
So, one more time.
Yeah.
Thank you very much, Donald. I appreciate it.
Yeah, thank you.
All right. Take care, everybody.
Bye bye.